Okay, it's 9:30, so I will let Shuping kick things off. We're not hearing anything, Shuping. I'm not sure if you're...
Hi.
That's good.
Hello. Okay, I will start. Hello, everybody. So we will start our session. And first of all, sorry I couldn't be there in person. And so now this is our first session of this week. And the dispatch working group and art area joint meeting. So first, this is the note well. And please, I won't read it, but please do go through it. And please follow the IETF precise and all the policies, and beware of all the BCPs here. And this time we were also suggested to add this note really well is about the anti-harassment. Please, if you have any concerns, please speak up. And there will be the team to take care of this. And since we are the first session of the week, so we spend a bit time about the meeting tips. And still this time it is a hybrid meeting. And for the in-person participants, and still you need to use the Meet Echo. And then, so here, this is the sign. And to join the make queue, the mic queue. And if you are not using the on-site version, please keep the audio and video off. For the remote participants, please make sure your audio and video are off unless you are presenting. And please use a headset. Here are some resources for this 117 IETF and agenda, Meet Echo, and other informations. And here you can also have the technical assistance if you need it. And this is first we will go through the dispatch meeting. Here is our agenda. And first of all, do we have any comments and on this agenda? So for the first dispatch session, we will have 4 items. And then we will go into the art area meetings. Okay, so please do utilize the mailing list to have the discussions. And we have the separate mailing list for the art area and the dispatch working group. Okay, so now we will start the dispatch topics, but please be focusing on this dispatch questions since we focus on the dispatching. Okay, so Jim, we can start the first topic. Thank you.
Great. Hold on a second. Let me get switched over here. Okay, unstable connection to the server. That's
disturbing.
no, not that one. That one. No, not that one.
So I should be able to.
There, I got it. Right.
Yeah,
Would you rather do it?
if you do that, then I have a remote clicker that I can use from here. So if you just approve right here.
You got it. And just to amplify on what Xuping said, remember, I mean, it's really fun to get into the details of the technology here, but really what we're trying to do is to find the best home for these different topics in IETF, or specifically in the art area. So let's focus on that. Whether we need to create a working group, whether this belongs in an existing working group, whether it should be AD sponsored, those sorts of questions are really the focus here. So I'll make sure that we have a little bit of time towards the end of this 20-minute session in order to address those things. Go for it, Justin.
All right. Thank you. So hello, everybody, and good morning, and welcome to the first session of IETF. I don't know if it's worse being the first on the first day or the first on the last day, but I've got working groups in both. All right, so anyway, I'm here to talk about a technology called Spiffy, and sort of the implications that this technology could have in the IETF, sort of things that Spiffy addresses and doesn't address, and what we think that the IETF might be interesting to address here in this space. So let's say we've got 3 different cloud services. These can be Lambda functions, VMs, doesn't really matter for our purposes. They're just services sitting out on a cloud architecture somewhere. They wake up, and we want to be able to provision these things with like secrets and certificates and identities and identifiers so that we can address them in different ways and stuff like that. And that's where Spiffy comes in. So with Spiffy, you run an agent on the system so that when these systems wake up, when these services wake up, they call this agent API that basically says, hi, I just got turned on. Who am I? What do I do? And they make that query using the Spiffy specifications. And you may also see a technology named Spire that is an open source implementation of Spiffy. And in any case, these services wake up, make this call to an agent, and that agent turns around and says, okay, this is your identifier. Here's the certificates that you need. Here's any keys that are associated with that. Here's your CA, your trust roots, all of that other stuff, just by virtue of you waking up in that space. Now, Spiffy does this by doing a node attestation. So these things are not pre-programmed with sort of a bootstrapping secret, because then it ends up being a whole other layer that you got to figure out, well, how do I get the bootstrapping secret in order to get into the secret store? Spiffy is all about solving that specific layer. And this is the first space that we think that there might be some alignment with work here in the IETF. And it's at this level that I think perhaps the art area might be the most interesting place for some of these conversations. When we show up with this new piece of software and I'm running in this space, like how do we tell what that is? How do we communicate that across the wire? And are there ways that we can actually standardize and do that beyond just the Spiffy API and platform? We've already got some existing work with RATs and the EAT token and all of that kind of stuff here. And there's going to be talks later this week about attestations in the OAuth working group in the SEC area. But this is a really sort of interesting space that a lot of good work is happening in. People are solving real problems in this space, and Spiffy is one platform where that kind of thing is happening, that it might be interesting. I think it would be interesting to bring that in here. So now that we've got these identifiers and certificates and keys and all of that other stuff, we can start to do some cool tricks. So we can use mutual TLS to communicate between all of these nodes now, because everybody's got a certificate and everybody's been programmed with the appropriate CAs, so that the yellow node knows that the orange node is the one that's making that call. The green node knows that the yellow node is the one that's making that call. It's works together really well. This is sort of at the core of what SPIFFE solves in data centers today. So you are chaining up all of these workloads, and they know who they're supposed to call and who's supposed to be calling them. However, that leaf node down at the end would really like to be sure that it was in fact the orange node that called the yellow node that called me. SPIFFE doesn't solve for that. MTLS doesn't solve for that. We need additional kinds of signaling to carry that kind of information across the wire. And this is, of course, a very, very simplified view of what a call chain could be. We'll get into more convoluted cases in just a little bit. But we think that this is a second area that there might be some interest in doing some work here in the standard space, figuring out how do I convey that kind of information. Is this even something on the TLS layer? I don't know. I think we need to start having the conversations. I see a lot of people shaking their heads. I'm with you on that by and large. I think this is at a higher level, but we need to figure out where that kind of thing lives, how to communicate that. All right, so let's throw some labels on these things. Let's say that that orange box is actually an API gateway, and that is calling the foo service, which in turn depends on the bar service. Well, the reason that we would set up a gateway is that we've got some external client application that is calling all of this stuff, and it knows to only talk to the gateway. Well, this sets us up with the situation that the client all the way over here on the left, that's the thing that has all of the access rights. That's the thing that's allowed to do this call. But that leaf node all the way down at the end, that's the thing that has the data to fulfill the request. So we need to be able to communicate in a secure way across that chain in a way that can actually be verified. And that's at the root of a lot of the next series of problems and use cases that I'm going to talk about. So in OAuth and similar protocols, we abstract out this concept. Instead of saying the client is calling a gateway, we say the client is calling a resource server. That resource server is internally made up with a gateway that's backed by a bunch of different services, but the client doesn't actually care. Like, it shouldn't actually care that what happens inside the resource server. The client just knows that I am making this API call. This is what I expect to get out of it. This is what I expect to put into it. And it shouldn't care about what happens inside there. This abstraction allows us to do some really slick stuff, like having an authorization server, abstracting the concept of the resource owner to get access tokens, and all sorts of things that we do with API protection calls today. We can even do sender constrained tokens these days, so the client can be the only party that presents that token in order to call that resource server. But OAuth, remember, ignores everything that's happening inside of that RS. And that's where the problems really start to come into play. So let's take that sender constrained access token, for example, and the client's the only thing that's allowed to present that. Well, we need to get that access token all the way down to leaf service in some way, because the access token represents the rights, the access rights that are associated with there. So we need to be able to get that information all the way down to the end, but the gateway, it can't present the token. It's constrained to the client. The foo service certainly can't. It's several orders in. So we need to either strip off the sender constraints, we need to wrap it with something, we need to replace it with something. There are a lot of techniques out there today, but this is a third place that we think this type of chained sender constrained access rights and token sharing, this is where we think that there is some really interesting work, probably in the SEC area. Once we get down to that leaf node, it's not just about the token, obviously. We want to be able to ask questions like, which resource am I supposed to be presenting here? That could be represented inside the access token or something that's figured out by the gateway and passed along. There's a lot of different ways to potentially open this up. And so we think that this is a fourth place that we should really be focusing on for use cases and conversations. And this expands really quickly to the fact that that leaf node, in many cases, is actually going to be asking a whole ton of different questions. Did the token come from an AS that I trust? Was it, which resource owner said that this was okay? Was it actually presented by the client? Do I have any assurance that it was presented by the client if it was sender constrained? And is the chain of services that got to me, like how this whole thing got to me, can I trust that? Can I verify that? And at what level do I need to know all of this information? And in a lot of cases these days, we just tell the little green box, don't worry about any of that. That's all been taken care of for you. And we have no way to verify any of this. And I think that we can do better. And this is a really big place where there's a big hole in the SPIFFE specifications, a deliberate hole in the SPIFFE specifications to solve more complex problems like this. This gets even more fun when we realize that that's not necessarily the end of the chain. That bar service can go call another API down at the end that is outside of its cloud infrastructure. We can have workload calls go across multiple different cloud architectures, multiple different deployments going through their own gateways and all of this. And so now we get to that final leaf node down at the end. There's a whole stack of things that it might need to verify at different levels of abstraction. And we need a way to talk about systems like this, and we need a way to talk about these types of concerns.
Hey, Justin?
Yeah?
If I can interrupt for a sec. There's been a little bit of chatter, and one of the questions that's coming up is, does this really belong in SEC rather than ART? So if you can kind of...
Oh, yeah. So I'm also presenting at SEC Dispatch, and we don't know where exactly this lands, and I'll get to that in a sec, because I think that there are multiple parts to this that probably bridges both spaces.
Yeah, I mean, people seem to agree that this is important, but where is the question?
Exactly, and that's why we're here. And finally, it really is turtles all the way down, because so if you missed the transition there, the AS and the client themselves probably have their own internal chains of systems that they have to call and verify in order for that call to be trusted by somebody in this system. And if you think that this is sort of complex and overwrought, like, financial systems are doing things like this today on a very regular basis. Like, one of these nodes is probably a compliance system and an auditing system that needs to make sure that everything that happened up to this point is actually any good. The SPIFFE project has been deliberately about solving that bottom turtle. That's what they called their book. When you boot up the system in sort of a cloud environment, how do you get that information into that? And then SPIFFE's kind of hands off what you do with that from that point on. The first question, and this is the part that is more, I think, a better fit for the art area, is that bottom turtle. These node attestations, this type of information, this whole concept of a workload identity and a cloud service identity. Do we want to, or do we need to address that, or even just parts of that here inside the IETF? And the second question, which, me coming more from the security side of things myself, that I think that there's a lot more meat to it, is, do we want to address any of the other turtles in that stack? Once we have that sort of idea of a workload identity, we can start building out use cases like I was just showing, and start to talk about and reason about the trust and the layering of all of those different pieces. So the next step is to figure out what the next steps are. This is where we are right now. We just got a non-working group mailing list, the Workload Identity and Multi-Service Environments, or WIMSE, because you shouldn't let nerds pick names for things. We're planning to propose a BOF for IETF117, probably non-working group forming. We're not sure yet. We really want to start these discussions. That's why I'm here at Dispatch, to kind of get this stack of ideas out in front of people. Some of this might belong in art. A lot of it probably doesn't belong in art. But we're at the stage right now where we're figuring out what the connection points between IETF and this whole world really ought to be.
Great, thank you. So we've got 3 people in the queue so far. Jonathan is first.
Morning, Jonathan Rosenberg from Five9. It's great to see this. We faced a lot of these problems in our cloud software, so I'm familiar with a lot of these. My question in terms of the IETF context is, how many of these are protocols that will span vendors? And that was sort of unclear. So if you go to the lowest turtle layer, for example, if the agent running on the pod talks to the whatever that server was that does the enrollment,
right?
If those are both software written and built by Amazon or written and built by Google as the cloud provider, and there's never a cross-vendor thing, then you might not need any standardization effort at all. So that's my question: is there clarity on where these things would cross boundaries between different vendors?
That is a fantastic question. SPIFFE is intended to allow that to cross vendors. In practice, it's by and large, people use the Spire open source project because it works and is deployable across lots of different systems. There are commercial implementations as well, Spiral, S-P-I-R-L being one of them. And you know, there are other stuff out there. It is intended, though, to allow that type of cross-vendor connection. I think one of the things that one of the perspectives.
Why though? Why? Like, what would be a use case where, like, I would deploy an agent made by the Spire team, and it needs to talk to a server, like, and it's an IETF question. Like, in my opinion, if it's the same vendor always, and it's just the client and the server are always made by the same piece of open source code, you don't need to come to IETF, and you don't need a working group. So that's why I'm asking the question. So
there's two aspects to that. One is I just downloaded one from one place and it was packaged in with an agent, and I already have an infrastructure running from somebody else. That's sort of the you know, to my understanding, that's like that was the drive for the Spiffy project to get started up in the first place. And the other one, which I think is more interesting, is if you start looking at these concepts at a higher level, so take them outside of the cloud vendor, you're ultimately looking at, how do I have a trusted way to map a sort of a service identification type of thing onto a set of trusted attributes, and being able to query that in an environment that may or may not actually be in the same cloud. So this has been deployed as a single sort of like within a cloud attestation, because that's the fundamental problem that Spiffy is solving. But, you know, let's say that I'm standing up in a federated identity environment. You know, I've got a software bill of materials that I need to be able to ship out to my auditing system to say, like, this is the right set of software that it's supposed to be here. Go check it out. And then they'll come back with, yes, hi, welcome to the network. Here's what we're going to call you. And here's the, you know, here's the trust bundle for this particular network. It's the same problem at a different layer. And so some of the conversation that we've been having in on this is like, do we actually, you know, can we actually extrapolate up to that?
Okay, but we need to move on.
Yes, sorry.
Okay, Philip.
I think you definitely need to hold there should be a working group forming BOF.
Eventually.
Whether it's art or sec, I'm kind of like iffy on, because, you know, you can make everything into a security area problem these days. The other thing is, this is actually a problem I tried to solve with WS security about 20 years ago. So you might want to, because, you know, we anticipated a lot of those use cases, and we did it so early that, of course, we didn't have the experience of doing the simple problems. So it might be worth looking at some of that to see what went wrong.
Yep. WS Star is a veritable treasure mine of interesting and sometimes good ideas.
Okay, Atul is next, and remote.
Yeah, hi. Hi, Justin and everyone. So just wanted to note a couple of related things that are going on in the OAuth working group. So this is mainly about that second turtle or second level of turtles that Justin was talking about, which is sort of the, you know, carrying the identity of the caller through the chain, making sure that every service is able to identify which intermediate services have been in the call chain and all that. So there's some work going on in a subgroup inside of the OAuth working group in the IETF. And there are a couple of talks on Wednesday morning at 9:30, one about transaction tokens and one about identity chaining, that are very much related to what Justin just talked about. I'll place the agenda of that meeting in the chat. So I just wanted to note that. Thank you.
Yeah,
Okay.
I want to note that is proposed work in the OAuth working group.
Okay, thank you. So any other comments about specifically where this should be homed? So do you have a clear view of the next steps here, Justin?
Yeah, I think so. It's still like Phil was saying, like, I think that it's unclear which area this will end up being in, which is why we're doing this at both dispatch and sec dispatch, to kind of get people from both general spaces, because it may end up being one of those weird things that kind of straddles areas in an awkward way, because we are dealing with, you know, workloads and things like that, and not just the security side of things. But yeah, our goal, like we said, is to propose a BOF. If you're interested in this topic, please join the mailing list. And we've been working on the co-presenters and I have been working on a set of use case documents that we're going to be posting to the mailing list really soon now, and hopefully that'll help really really kick the conversation forward. Oh, Brian's on the queue. Nope.
No,
Brian is not on the queue.
Nobody on the queue.
Okay.
Oh, here comes Murray.
Hi, Murray. I'm just, if you're going to do this at Sec Dispatch as well, we're going to have some dialogue about if you go to a BOF, which area should it be in and all that.
Yeah, totally.
So whatever we decide has to be coordinated with Sec Dispatch. That's all. Are they? Do you know what? You know off the top of your head when they're meeting? Like maybe I can try to go to that.
I think it's tomorrow afternoon.
Tomorrow afternoon. Thanks.
I can't remember.
I think it's tomorrow afternoon, if I recall. I don't remember which session.
I can look it up. That's fine. Thank you.
Yeah. Tuesday session 4 is the answer.
And Colin is in the queue.
So thanks for presenting this. We use this for some of the use cases that you talk about for tracking for security devices to understand what happened to a session. So if a virus shows up later, we can sort of track back where it was. Yep. So it's sort of used for logging information as much as anything else, but we do use it. I mean, I think it's great, but I think the work you're proposing doesn't actually have much to do with security in the sense we're not the work to figure out how to create these certificates, what the crypto is in them, how they're signed, how they're validated, all those types of things is largely already solved. That's not what you're talking. What you're talking about is transporting these around. So I would put a strong argument of, running this as a BOF in the art area and making sure it didn't conflict with anything badly in the security area, or until working cross with them type thing. But I think that's where it's going to land. But if you do it the other way around, I don't think it makes any difference anyway. The outcome's the same. It's no big deal. Just talk to the ADs of both. They're going to have to both coordinate on this. Yeah,
thank you. We had a similar feeling, and for those that didn't see, there were a handful of thumbs up in the room to that comment.
Okay, well, it sounds like that's our outcome. Thank you very much for presenting, and we have SAD CDN coming up next.
All right, thank you.
And I need to... Hang on a sec, I got to figure it. There we go. Which sounds like a sad Canadian, but all right, go ahead, Matt. Do you want to control the slides?
Yeah, I'm trying to. I'm not sure.
I need to grant that. So
okay.
There we go.
Just make sure this works. Okay. Hi everyone. My name is Matt Joris from Meta. I'm a software engineer and ancillary data enthusiast, and today we're going to talk about my draft, which is securing ancillary data for communicating with devices in the network, or SAD CDN. So these are our topics for today. First, we're going to talk about what is our problem. Specifically, we're going to talk about a motivating use case for this work. This is not the only motivating use case we see for this work, but it's the one we are focusing on today. Then we're going to go into the existing solution landscape and why maybe those solutions are not really working for this problem, which leads us to what we view as the need for standardization in this space, particularly from the IETF. And finally, the dispatch question. So diving right in, what is our problem? So overall, the use case we're focusing on in this presentation is what we're calling adaptive video traffic shaping. So this is a very common practice by mobile network operators, or MNOs. It is also sometimes referred to maybe not as shaping, but throttling or policing, depending on the context and the particulars. But this is overall the thing we are talking about. And the overall goal of this is to try to limit the video bitrate of adaptive video. So stepping back a little bit, what is adaptive video, or ABR as I'm going to call it? So In this diagram on the left, we have a mobile client. So this is the mobile client that is trying to play a video. We'll say it's accessing the internet via a 15 megabit per second radio link, just for argument's sake. And on the right, we have a content server that is serving this video. So the way these ABR schemes work, if you've heard of things like HLS or Dash, is that the client at the outset of playing a video knows certain things about the video being played. And so these videos, instead of encoding a single video as 1 bit rate, they will typically break it up into 1 to 5 second segments and encode that with different bit rates, which correspond to different quality levels and resolutions. So that's what we see on the right here. These are, for a given video session, the quality lanes or qualities that we have available, and the client knows this. So the overall goal of an ABR scheme is to adapt to changing network conditions to try to maximize quality while minimizing frustrating experiences like stalling. So looking at the timeline we have in this little diagram, the way this might end up working is that for the first video segment, the client will try to fetch, say, the 1 megabit per second quality. It sees that this downloads relatively quickly, and so it says, okay, I'll try for the 20 megabits per second. However, the network in this case, since it's a constrained link, is not able to sustain this, and so that causes a user visible stall. This causes the ABR scheme to back off, and it will instead fetch the 10 megabit per second quality lane, and it stays there for the rest of the playback. Okay, so what does this have to do with shaping? So the key thing to note about shaping here is that video in modern mobile networks often takes up the lion's share of the traffic that's being served. And so this is costly both for the operators, but also potentially for the users. And so there's a desire to limit the bit rate that is being played back to trade off the experience of the user while also serving the needs of things like avoiding congestion in the network, but also, avoiding things like data overages for the users. So the mobile network operator, to achieve this, puts a shaper or a policer or a throttler, whatever you want to call it, in the network. This is typically implemented with something like a token bucket that is configured to try to hit a certain target bit rate. So the desired outcome in this case is for the overall quality to be limited to the 2 megabit per second quality lane. So going back to our timeline, how does this end up working in practice? First, the client, as before, tries to fetch the 1 megabit per second quality, sees that this downloads relatively quickly again, and it increases the quality it fetches to 5 megabits per second. However, due to the presence of the shaper, it's not able to sustain this delivery, and so there's again a user visible stall. This causes the ABR scheme to back off, and then we end up with fetching a 1.5 megabit per second video. So this all seems fine, right? The goal was to limit the quality. We put a shaper in, we configured it, and the quality was limited. So what's the problem? Well, it may look good on paper, but in practice, there are a lot of difficulties here. One of the key things to note is that the shaper is an artificial limit on the network's delivery capacity because it's pretty much configured to be a set point. And by running the traffic through this shaper, we inevitably end up with periods, sometimes long periods, of underutilization of the network resources. And this has downstream effects for things that you might not expect, like the radio equipment is not able to optimize its spectrum usage because it doesn't have necessarily enough data available, and it just causes a scheduling problem. Another thing that is difficult about this is that these ABR schemes, while they seem like they'd be relatively simple to do these heuristics, in practice it's very difficult to get this right in a general sense. And so they don't converge quickly. They end up causing frustrating experiences for users. Anyone that's played video on the internet has seen this, where there are stalls, the quality goes down, it goes back up, it ping-pongs between qualities, and this is all because it's trying to apply heuristics to a complicated system. And then that's before we even talk about the struggles of the content server that's actually sending the video data. So as all things on the internet, it uses a congestion controller, but these congestion controllers in practice are not great at dealing with token buckets in particular, or really any form of shaping. And this is a really difficult problem to solve, and they basically just make everything above worse, because when these shapers are composed with other forms of organic congestion, for lack of a better term, it's very difficult to know what exactly is going on. So we talk about all the problems, but is there a better way to do this? And there is. The better way to achieve, remember that what we're trying to achieve here from the operator perspective and from the user perspective is limiting the quality. That's what we're really trying to do. And so to do that, a much more direct approach is to just have the content server cap the bit rate. So everything is the same as before, except for now, when the mobile client is trying to play back a video, there is a maximum of the quality. So all those higher quality lanes are not available. So,
Matt?
Yeah.
Just kind of try and keep it at a top level here. I think people are understanding the problem that you're trying to solve, and so we're really trying to find a home for this work.
Yeah, I'm getting to that.
Thanks.
So basically what happens is that you're able to converge on the quality level without causing a stall, because there's no discovery needed by the client side. So the problem here, though, is how does the content server know to do this? And this is where we get to the core issue here, is that we don't have a way to communicate this. And so getting into what could we use to communicate this? Well, we need to solve basically for information disparity, where you have the client, the network, and a content provider all being able to exchange information in a cooperative way to achieve a certain end. So what could we use today to do this? Well, there's in-band network signals, so things like ECN, DSCP, IOP options. These are all things that we're familiar with that we use today to communicate various things from the network to the endpoints. And then there's out-of-band things where people may be familiar or not familiar with these, but these are things where mobile network operators will stand up certain API endpoints that can be integrated with the content endpoints and exchange more rich information. However, there's problems with both of these existing places. So for the in-band network signals, they have a lot of appealing properties from an implementation perspective, but the ones we have available today, the core problem with them is there's very limited information fidelity available. So if you think of things like ECN, people might say, oh, look, you're just trying to solve a congestion problem. But ECN is really only designed to expedite the delivery of this information. Rather than having an implicit signal from congestion being detected, it's just telling you explicitly. But that's not really what we're trying to do. We want to know a richer kind of information, like, hey, I want the application to change behavior. So ECN is not really fit to do that because it has limited information fidelity. And if you try to increase the information fidelity, you will run into the problem of, well, ECN and these other things are inherently visible on the wire. And that's not great, because now we're going to have the opportunity for pervasive monitoring. And then for out-of-band APIs, they frankly just aren't going to work for something like this. They have a lot of scale problems. They have high complexity for basically every party, for the operators, OEMs, content providers, and they're also not suited for conveying this sort of real-time information. They do allow you to convey arbitrarily rich information, but not in a very scalable or realistic way. Additionally, there's not really a lot of consensus in this area right now in the industry. And that brings us to the need for standardization. So how do we take those sad faces and make them happy? Well, we've got basically 4 principles that we want to achieve here. So the first is that we want this information exchange to be secure and with standard cryptography for very obvious reasons. But this also allows for things like if you have to solve for authentication, how do you trust it? Well, we've solved these problems in a standard way, and we should leverage that. Another key thing is in-band session establishment. For exchanging this information, the only way it's realistically going to be achieved is to do it in an in-band way. Anything that requires an out-of-band party is not going to be able to scale for this kind of information exchange. Another thing is we want to maintain transparency with the end user and also maintain privacy. So today, for example, end users are not really aware that any of these kinds of things are happening. They don't know about the shapers. They don't know about the policies. And this is an opportunity to solve that because we are able to exchange that information and then we can surface it potentially in a user interface. And of course, the most obvious thing is this has to be an open interoperable standard. If we want everyone to do this, if we want all operators, all content providers, and all OEMs to do this in a cooperative fashion, it has to be an open interoperable standard. And that's why we think that this is potentially good work for the IETF. Which leads me to dispatch. So what now? Probably a lot of people here are getting vibes of similar work having been done in the past with varying degrees of success and cataclysm. So we're aware of that. There's a lot of ongoing work that's kind of in this area, but none of it's really centralized, and it's not exactly clear where this belongs. So what we're here today to find out is, are there others facing similar problems? Not just like this video problem, but any problem where the network and content endpoints can cooperatively exchange information for better outcomes for everyone, and facing similar constraints around security and privacy. And yeah, so that's pretty much all I have. There's a side meeting I want to flag tomorrow that if you're interested in learning more details about how we think this might work and other perspectives from OEMs, please show up there.
And one of our remote participants asked if there was an online link for the side meeting.
Is there what?
An online option for the side meeting?
Yes, there
link
is.
For that?
Yes, there is.
Okay. And
yes, it's on the side meeting wiki.
Okay, great. Thank you. All right, we have a few people in the queue. Ted is first.
Ted Hardy, explicit signal enthusiast. So thanks for the presentation. The dispatch question here is, I think that this needs to have a BOF in order to deal with the large-scale concerns of the IETF as a whole around how explicit signals leak other information. And so I would suggest a BOF with an explicit portion of it addressing privacy and leakage concerns as part of the setup for the BOF.
All right, Alyssa is next.
Alyssa Cooper, thank you for this presentation. I agree with what Ted said about the dispatch question. I was curious if it's difficult to get consensus, like let's say you had something Kamara-like, but it was more suited for real time, and the interest involved find it difficult to find consensus around something like that. Like, what would be different about doing it here that would make consensus more likely?
So that's a very good question. From my perspective, the main thing we think is better about the IETF is the engagement services. So a lot of the out-of-band stuff is driven from the operator side versus and there's many operators, and there's a lot of incentives involved in that space, whereas this kind of solution that's more protocol-y, for lack of a better term, what we really need is agreement and consensus between content endpoints and OEMs, the equipment, the people that are actually implementing this stuff, as a much smaller space of people that already have an existing way to work on similar things like protocols. So you still have to obviously engage with mobile network operators and this sort of thing, but there's an existing way for us to work together with content endpoints and OEMs. And so that's why we think this is potentially an easier path to get consensus is at the IETF. Does that answer your question?
It does. Thank you.
Okay, Richard Barnes is next, and we're getting a considerable queue, so I'm going to have to close it pretty soon.
I'm Richard Barnes. So also like Ted, team explicit signals. So yeah, I was glad you characterized that taxonomy to like help clarify those distinctions. I note in your draft, this kind of solution sketch is looking at explicit signals kind of in the way that like SPUD or ECN does in terms of signals that emanate from the endpoint. I was wondering, like, if you thought that signals that emanate from the network toward the endpoint could be a workable solution space here, because that seems like it might have some better privacy properties and leakage properties.
Right. So we see this potentially going both ways, for lack of a better term. So being that there's in the draft there are actually two use cases presented. One is this, and the other is packet prioritization. Those are directionally different. So, for example, this one, the constraint space would be communicated from a network device to a content endpoint, acted upon by a content endpoint. For packet prioritization, it would go the other way. It would say content endpoint originates this information, network acts on it. And we think that there's an opportunity here to develop a single channel that covers both use cases so that we aren't having to potentially reinvent the wheel every single time we want to do something cooperatively. Does that answer your question?
Yeah. So that's good. So I think as we're kind of refining the taxonomy of things here, I think that's another useful distinction to have, because it seems like we might be able to make progress on one bucket of those use cases
Yes.
and not the other.
I agree with that.
Okay, Ali Bacon is next.
Hello, this is Ali. Thanks for the presentation. This pacing stuff for traffic shaping, whatever we call it, has been around for a long time. And then we have done some standardization work in MPEG actually called Server and Network Assisted Dash, where we do this kind of signaling within the transport itself. So the security actually belongs to the HTTP layer. And then later on in CTA, a couple of years ago, we completed the specs for common media client data and common media server data, which allows bidirectional hinting between the server and clients. So I'm not sure whether you are familiar with those works or not, but that's definitely something you should check.
Thank you.
Thank you. Magnus?
Yeah, Magnus Westlund. I think there's much more interesting use case around this using this signaling, and I think there's clear potential here of actually solving some of the criticism against SPUD Plus because of security, actually having explicit secure identities and all those things, which was in the generalized case is very hard. So, but I guess we're gonna have to go the route of BOF. I see that as reasonable, but let's come discuss more tomorrow. So,
okay, Harold.
Harald Alestram. Just, I think this problem is more complicated than you made it out to be. Ouch. I mean, I was considering the fact that if you have a game download, you want to get that at maximum speed so you get it out of the way. If you have a video playback, you want to hit a lane, which means that the network has to be told whether you're watching a video or downloading a game. And the only way you can know which lanes of video are available is by communicating between the endpoint and the network and the service provider. So I see this as a means that could expose a terrible amount of information about the user to the network, about what the user is doing, if not done carefully. I also see it as requiring things to happen ahead of time when you set up sessions. I mean, normal HLS transfer is TCP, but you choose the bandwidth to aim for before you send the SYN of the TCP session. So, very complicated problem. I wish you luck.
I'll just respond to a couple things. Yes, it is a very complicated problem. The other thing, what you said about leaking information, I think it's important to note that this is already being done. That like these shapers, they exist today. This is not like a hypothetical thing. Traffic is already being identified generally by extracting the SNI, and so video traffic is already being specifically targeted and shaped. So by having this channel, though, you would still communicate that information, but you would choose the content endpoints would have to be in control of what is shared. So that is that part. What you said about the bit rate being chosen before the connection, that's not true for ABR in general. It is adaptive. It is done segment by segment. So
okay, we're just about out of time for this segment.
Each segment is a separate TCP session. It's a terrible design.
No, it's not. It's not a separate DTV session. Anyway,
Let's move on. Please, people at the mic, please announce your name and eat the mic so that we can hear, the remote people can hear you well.
Dan Drutze, AT&T. You have questions on the screen. I think the yes. Yes, it is a hard problem, as Harald said, but I think it is a good time to resurface and look with different lens, with what Ted said about the privacy considerations and explicit communication between network and devices and network and endpoints in the cloud. I do think that the proposal is a little bit vague in terms of where and how the information is being sent, maybe a little bit too chatty, but it's a good way to start the conversation. And I do think that it's right time to start thinking of a BOF or something more formal to get the ball going. Thank you.
Okay, we're actually out of time for this segment, but what I'm hearing is art area BOF. Is that consensus from the crowd here? Yep, getting nods and a couple thumbs ups. All right, well, thank you very much, and I guess that's your dispatch outcome. So Kaiser is next. I will. And then you want to control it?
Sure.
Sounds good. Here we go. SDP security assurance, right? And you need to request to control the slide. Which one? I'll let you do it. It's not slides. Okay.
Hello, everybody. Hopefully you can hear me in the back. Thumbs up. All good? This mic's better than last time. Cool. So my name's Kaiser Davis. I'm with Cisco Systems, and really quickly want to talk about a problem that I called STP security assurance just because I didn't have a name, but it's still a working title. Next slide. So what we're talking about here in the problem statement is that there's a really important value in the SRTP cryptographic context that is not signaled on the wire or shared amongst applications. And when I tell this to administrators or I tell this to software developers, they kind of scratch their head and say, why did we do it that way? And I don't know why. I wasn't around when we wrote the original specification, but even in the original specification, we cite some examples where, we might need to share this on the wire, but we just didn't do it. So my thought today is, how do we share that value on the wire? So one of those main values is the rollover counter. The rollover counter is something that we kind of locally manage and maintain. And because it's never explicitly signaled, it's super easy to get out of sync. And when you get out of sync, you have packet decryption problems. And packet decryption problems lead to usually no audio, no video, sour user experiences, and lots of developer time trying to figure out who's at fault, pointing the finger at each other and saying, where did we all go wrong? Currently at the moment, we have a lot of different key management protocols for SRTP, and most of them handle explicit signaling of the ROC. And that's pretty cool, but we've kind of forgot about STP security. And I know STP security at the moment is kind of the elephant in the room. We don't like it, but it has a very huge install base, and it's good enough for most people's security applications if you layer TLS on top of something like SIP. So we've got a lot of interesting problems, and it really is super simple to solve. Go to the next one real fast. Some of these scenarios I want to talk about real fast, just some highlighting 6 of these are ongoing broadcast sessions where we join a session and we're blasting media everywhere. Somebody has to join up and understand that cryptographic context. And, if this session's been going on for a while, that rollover counter might have happened, and there's no way to tell that new participant. That's not a very common use case nowadays, but it's theoretical. The hold resume transfer is probably the most common type of scenario that I see out there. You've got party A and B talking to each other, put a call on hold, you transfer party A to party C. Now party C resumes a cryptographic context of some type, and they're kind of out of luck. Or you might do a hold, and that's with A and B. You bring in a server to play some music on hold or something like that, call them C. Something happens, we roll over during that session, we bring the session back to party B, and we had a rock rollover. And there's no way to tell that party B that, hey, we had a rollover during the time you were gone. So there's a lot of different scenarios there where I see problems, and it generally, interop between different vendors, because that's kind of why I'm here today. We've got application failovers, and if you don't have a stateful sync or some sort of proprietary logic in your clustered high availability application to share this data amongst your nodes, it's not easy to kind of get that new information on the wire. A theoretical scenario that I put together is if you're using secure SIPREC recording and you might bring in the recorder later in the session to start that recording, maybe via button press or some sort of application logic, there's no way to tell that SIPREC recording server via STP security that you need to instantiate with ROC of 1 or 2 or some other value. There's a lot of other scenarios where ambiguity in the original RFC kind of led to improper resets of the SRTP cryptographic context. So for example, I may inadvertently think that a key change should reset the ROC to 0. And we have a lot of finger pointing that always happens with, hey, a key doesn't necessarily indicate that we should reset the ROC. Well, we can kind of solve those problems by just saying, here's my new key, here's the ROC I'm going to use, and we feed that to the SRTP generator and makes all of those issues go away. And lastly, the original RFC had kind of this misconception that there was no late joiner. And I've mentioned a couple of scenarios where there's late joiners, and there's probably tons of other ones, but we bring in participants to sessions very late all the time. So we kind of missed the mark there. And that was the original reason why they kind of didn't put this on the wire. I see this all the time. And it's, for the past 6 years, been really a pervasive problem that I've been working to solve with many different folks in my industry. And I just think that it's time for us to get together and just say, let's put this thing on the wire. Let's discuss the format in which it needs to be conveyed, and then do it. Next slide. So real quick, comparing those key management solutions, STTP security, we don't have a way to convey this. DTLS SRTP with EKT SRTP can convey the ROC in the SSRC, 2 values that need to go together. MyKey, which I don't see in a commercial offering very often, has a method to convey the ROC in the SSRC, but it's there. I'm not sure how ZRTP handles this. I looked through the spec and some supporting documents, and I'm not sure if they ever solve for this problem. I know that H235.8, which is kind of a delta of STP security, which has been morphed to put into a packet for H323 purposes, based off of A.crypto, does not have a way to do this. So if we kind of solve this problem, H235.8 can also potentially reuse that. So there's some downstream dependencies. Next. So the question everybody says is, why do we update STP security? Now there's tons of enterprise endpoints, whether that be the actual phones, endpoints themselves, conferencing, B2B UAs, PBXs. I see conferencing solutions, service providers, and even cloud offerings where we might be doing UC as a service in a cloud conferencing, or even just registering endpoints up there. All of these different things are still using STP security today. I know on the mailer, some folks have said, hand wave, make this go away, just use DTLS SRTP. Well, that came out almost 10 plus years ago, and we're still not using it. So can we really dismiss the whole thing when we're not even at that protocol that at this point is kind of set in stone and pretty good? But what's it take to get over that hump? And I think that we haven't reached that critical mass for DTLS SRTP. So let's, solve this for STP security, fix this problem for the majority of endpoints, and kind of go from there.
Clarifying question, Ron?
Yeah.
Name,
Rowan May,
please.
Wire. So that same argument, I just would like your view of the flip side of that, which is, if somebody isn't willing to go and implement DTLS SRTP, why would they be willing to go and implement this instead?
Yeah, so I think the easiest thing to mention here is for solution A and B, they're very simple and they're built off the A=crypto. So it's almost a very simple library update for something that they're already using versus a DTLS SRTP, which is a much more robust solution and requires a lot more code implementation and test coverage and planning versus there's a new couple things we have to parse out of the STP value. So it's a little bit easier to implement, that I think that we could get this across much easier. I hope that answers the question. A good one. So going in here, solution A and B, we'll look at on the next strategy or next page. I kind of have two different ways I've been looking at doing this, and there could be different ways. But solution A just reuses the STTP security session parameters, which if you're not, if you don't know what those are, which I didn't for the longest time, are kind of the post-fix optional parameters that are at the end. We've got a couple different ways to do this. You can put a key value pair, and in here I put the SSRC, you put that value, the ROC, I put the value, and the sequence number, because there's some scenarios that I'd like to address with a sliding window that also happens when we kind of bring in late joiners. And you can signal these three values of the packet index pretty quickly here at the end using a key equal value pair. And it's all part of the original spec, so adding some of those values shouldn't break things too much, I wouldn't think. And then solution B, which is currently in the draft 00, which is up on IETF right now. The way I did this originally before knowing about the optional session parameters was I just made an SRTP CX, a STP attribute, and I added those three values there. It kind of mimicked the FMTP attribute where it's just key value pairs separated by a semicolon. And this is currently what draft 00 has, but solution A is what I've written in draft 01, which I should be able to submit after this meeting. And it kind of just uses those. But this is what I originally had. So if anybody's looking at the document right now, this was the solution on paper, which I think, in my opinion now, isn't the best. And I think solution A is where we would go.
Okay, I think that's it for slides.
Yep.
Comments? Richard, you were in the queue. I guess you're not anymore. Maybe you are, actually.
Yeah, I was waffling a little bit about this question, but it seems like both of these solutions presume that the SDP entity, which is, it's a signaling layer sort of function, is involved in the media layer, so it can see things like the rocks and sequence numbers that are using. Is that like an architectural challenge for you?
I think that most of the places where this is used, the media does flow through, or if it's not something that's involved in the media, it'll pass it from like leg A to leg B. So you get kind of this pass through of these parameters. But yes, generally where I see these things, the media is anchored and flowing through that device.
Magnus Westlund, one of co-authors of Estes should die, but yeah, I actually think there's an interesting question to this in relation to dispatching it, or if it's etc. And that is this an STP, or should it be done in the media plane itself? So saying one solution here would be saying, oh, we just need a way of distributing the EKT key, and you could deploy EKT without the DTLS. You would actually have the same properties.
Yeah.
Yeah. So, and my other aspect of this is, in some sense, the information you're actually sharing here, none of it is secret. The only thing which relates to security of this is, can you trust this? Because wrong information is the denial service vector for the service. So I think it's something that you need to trust, but it's not secret in any way.
Okay, Jonathan Lennox remotely is next. Oh, you're not remote.
I'm just using the full client so I can see the chat. I'm just using the full client so I can see the chat. Yeah, I'm not sure if this is a good idea, but if we are going to do it, I think the dispatch question, assuming that we go with this approach and not the one Magnus said, I think the dispatch answer is MMusic. If it's, it's an MMusic should decide, is this a good idea or not? But I think that's clearly the home for it if we're going to do it.
Okay. Philip?
Phil Hambaker. Yeah, I've been trying to grovel through the WebRTC and all the video, and so coming to it having ignored it for 10 years. And it's really difficult to find out what is actually going on and how to make it do things like, oh, I've got this post-quantum key exchange that I've already done. How do I stop that being thrown away when the DTLS stuff comes up? How do I get conferencing to work well without and still have security that is end-to-end secure? And oh yeah, and I'm using a whole bunch of threshold cryptography which isn't in the standard repo. I think that if you have a group, a working group to just make this stuff work would be a good thing to do. and this would be one of the working group items. But I think that just taking individual bits that don't work in the patchwork of what's been developed over 15 years, whatever, trying to build on things like DTLS, and also insisting that you must do it this way, and also that whole W3C interaction, I think that there's too much complexity there. And just patching one problem is not worth doing. I think that we should have a BIS sort of working group.
Colin.
Colin James, Cisco. So let me just start with, I agree that probably music is the right place to discuss this stuff from a dispatch point of view. Sorry, music is the right place to dispatch, to send it. There's a working group charter to deal with this, like let's send it there, right? This seems to be within their charter to me. That said, I would want to start this conversation with getting very specific on which use cases currently don't work or have lots of interoperability problems because of ambiguity. Like if it's something as simple as dealing with, we need to be clear about if the rock gets reset when you put a new key in or something, like that's a bug in the spec. That's not something that needs a new spec. That's purely like that needs a clarification in the existing spec. But if it's something like there's use cases where we really need to signal this, and you won't, you know, when you show just a fragment of SDP like that, you miss that SDP is an offer answer transaction, and we have to show the whole transaction and how that gets to. And a lot of the cases where this went wrong wasn't actually a problem with the keying. It was a problem with somebody was trying to insert a recording service into an offer answer thing without being a party to the offer answer. And you get into these sort of complications. So I think it should really focus on the use cases is where we should start of which ones do we need to solve that aren't solved today.
Jonathan Rosenberg, 5'9", music. I'm in favor of proceeding with the work. Listen, we would love it if the world was all DTLS SRTP. It's not. We would love it if the world was IPv6. It's not. This is part of the real world practical dealings of maintaining protocols that have been standardized and widely deployed. And this is a maintenance project. Let's do it. Fix the patch, you know, to add the signaled information that was missed and the concrete use cases we have to solve for. So I'm in favor of proceeding with this practical piece of work. Thank you.
Murray.
Jonathan, do you agree with the idea that this might fit under music's charter? Could go over there. Okay, that's what I missed that meeting part. Thanks.
Okay, and it sounds like that's the end of the queue. I guess what I'm hearing is that the consensus is take this to music. Is that correct? Several thumbs up in the room. Okay. Thank you, Kaiser. And the next thing is, I think, Donald presenting on S expressions. Oops. Wrong button here. Okay, do you want to control or do you want me to control? I might as well control, I guess. Okay. I guess you request that first. I think there's something you have to do to request control, but I'm not sure what it is on the client. If not, I can just do it.
You can do it. Hi there, I'm Donald Eastlake with FutureWay Technologies. Is this better? Yeah, okay. Donald Eastlake with FutureWay Technologies. And this is about S expressions. Next slide. So these are data structures for representing complex data, either byte strings or ordered list of simpler S expressions. And if you look at the document, they were designed taking into account a lot of different considerations: readability, transportability, flexibility, efficiency. Also, be sure there was a canonicalized form so you can do digital signatures and verification over them and things like that. And they have lots of different representation options. You can have quoted strings. For a byte string, you can have a token if the character set, the byte values are sufficiently restricted. You can have a hexadecimal base 64, so you can get it into a form where you can pump it through some channel which is sensitive to peculiar byte values. And as I say, a canonical representation for security reasons. Next slide.
So up here. There we go.
So here's examples of a 3-byte sequence, hex 61, 62, 63, which frequently interpreted as lowercase ABC. So you can quote it, you can represent it as hexadecimal. The verbatim canonical encoding has a decimal number and a colon for the length, and then you have arbitrary values in the bytes after that. You can base 64 encode it, or you can base 64 the verbatim encoding even. And there's also a provision for a display hint, which might be a MIME type for byte strings, which would be some hint as to what kind of character set it is, perhaps, or things like that. So a list, simply open parentheses, 1 or more S expressions in a closed parentheses. Actually, 0 or more, I guess. Next slide. So that's actually a slight error in this slide, I think. So what is this stuff? Why is it we're talking about it at all? Well, they were developed quite a while ago by Ron Rivest, who's given explicit permission for me to do this effort here. They were developed for this simple distributed security infrastructure by Lamson and Rivest in 1996. The origin of the term S expressions and this sort of thing does go back to McCarthy's Lisp programming language, but these S expressions are a little different. They were further refined when SDSI was merged with the simple public key infrastructure in 1997, and there's actually referenced from RFCs 2692 and 93. So at the time, there was a file, draft Rivest SEXP00, which was made publicly available and is referenced from these RFCs and so forth. The whole IETF thing was a little less formal in those days. And in fact, this draft was never actually submitted to the IETF. So it has never been made into any kind of permanent reference or anything like that, which is sort of what the goal of this effort is, to update that draft to sort of modern standards and get it issued as an informational RFC to make a permanent reference for this idea, which is referenced from these other RFCs. Next slide. So that's what this says, make it a permanent reference. And there are changes. This been updated to modern format and put an XML source and so on and so forth. Has a IANA consideration section in it as required, even though there aren't any such IANA considerations and so forth. The biggest changes, however, were replacing the BNF, which is somewhat ad hoc, with the current, more standardized ABNF from RFC 5234. And Mark, who's listed as a contributor, is the one who actually did most of that work. I did most of the other stuff. And probably the biggest change is to change the default display hint for a byte string which has no declared display hint from text plain charset ISO 8859.1 to somewhat more modern UTF-8. And that's probably the biggest change of substance. Next slide. So that's really kind of the summary of what's going on. And my opinion is that AD sponsorship is probably the way to go forward. And I'd be interested if people support that or have other opinions. By the way, Ron Rivest, he was actually traveling today. I don't know if he would have attempted to join remotely if that weren't the case, but he said he would not be available today. So.
All right. Thank you, Donald. Any comments on this?
Pete Resnick, is there a reason for AD sponsorship over ISC if this is going to be informational? Someone made the comment in the room, doesn't seem like something that needs consensus of the IETF and all of that mechanism. Seems pretty straightforward to give to Elliot and get it published quickly.
I don't know that there is that much of a reason one way or the other for those things. I guess, what's the story on directorate reviews for things that go through ISE?
Yeah, it doesn't go through directorate reviews. Elliot has his own.
I know there's an editorial review board.
Right,
I put
and so
documents through
he
that channel.
solicits,
Yeah.
appropriate editorial review for the document. So it'll, you can suggest to Elliot, hey, get a couple of these people to read the document to make sure that it's kosher, and then off it goes.
So I guess I would say I think the AD sponsored process is perhaps more lengthy, but
And that's the
thorough.
question. If you think it's worth the investment of directorates and other things to get that kind of read over, perhaps it seems like a lot of mechanism for what is basically cleaning up a document that's not going to really change all that much from its original state. So ISC just seems to be a less intensive kind of process to
I would agree it's less intensive.
Phil Humbecker, you've got no design scope here. The only thing that you can do is change bugs. So I think ISC would probably be the simplest and the best.
Joe was next, I think.
Sorry. Yeah, Joe Salloway. Yeah, I think either one, ISC or AD sponsored, it doesn't make too much of a difference to me, I think. And I'd like to see this go forward. I mean, I think it's an interesting thing we've used it in various places. So I think it's definitely worthwhile to do.
Okay, Jonathan.
Jonathan Rosenberg, 5'9". I guess if it goes at all in the ISC, I agree. It just doesn't need any consensus. My question is, why do you even want that? I mean, like, it's not like there aren't other publishing vehicles on the internet. Like, put it on a web page. Was there a particular reason you now woke up and said, "Oh, let's make this an RFC"? That would need. I mean, we got lots of stuff that never got documented in RFCs.
Was Mark going to say something?
Oh, Mark, you can just answer the question if it's for you. Why are you guys doing this?
At the microphone, please.
I am not on the queue, Mark, but you're gonna. The whole reason we are doing this is that the reference disappear from the internet, right? And this is why we want to have a reference. As it was published as an internet draft, why not going all the way? Why not going, sorry, why not going all the way and making it an RFC? IEC is probably the right way to do.
It's basically will make it more permanent and accessible.
Yeah,
rather than a draft.
Also, so.
Yeah. And it was a draft floating around, and it disappeared and wasn't floating around, and you can make it float around again, but
well,
why not make it permanent and accessible?
And it's already substantially in the format of a draft, right?
The current the -02 draft, which is in the Internet Drafts Directory, is I think meets the modern formatting standards and everything, is an appropriate internet draft as far as I know.
Okay, I think Rich.
Rich
Yeah.
Sit down, Barnes. Rich Salzak, yeah, I think ISC makes a lot of sense because, as someone pointed out, it's not going to get changed very much. We've done a lot of documentation of other things before in the security area. Various algorithms were written down even though they kind of existed. This is kind of a neat technology. There are some people who use it. I won't mention how old some of our code is that uses something like this. So yeah, ISC, I suggest.
Daniel Kahn-Gilmore. I'm also fine with ISC. I would be okay with AD sponsored as well, as long as this is really just documenting what is out there. I do know that there are people who are actively developing S-expression tooling, which I think is a little bananas, but it's happening, and some of them are changing S-expressions or embedding them in other contexts. And I'm hoping this draft will not try to extend S-expressions.
It hasn't so far, and I didn't intend that, and I don't think the other authors and contributors plan to do that. The only real change was the change in the default display hint from the ISO character set to UTF-8.
Richard Barnes, just a minor point of process order. This group can't say anything about what the independent stream does because it's independent. But that said, our job is to decide what the IETF does, and I think that like the IETF doing nothing on this is the right answer. And if Don wants to submit it to the independent stream, by all means.
I didn't quite understand.
We can't, this group can't tell you to go to the ISE because it's
Yeah.
independent, but we can say the IETF shouldn't do any work, which is, I think, what I'm hearing here. And if you would like to submit to the ISE, it's up to you.
Sure.
So it's sounding like it's between AD sponsored and ISE, so maybe we should hear from the AD.
I'm hearing a lot of support from me not doing this.
I don't know.
In addition to, if I were to say that I would do it, my queue is very long right now. So you would be, ISE is going to be faster, and it seems like that's can't quite, like Richard said, can't send you there, but like I can quietly point in that direction.
That seems like an excellent point. Thank you.
All right, so it sounds like the dispatch outcome here is do nothing and subtly point at the ISE.
Okay.
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 Okay. Thank you, Donald. Need to change the slides here and so forth. I think we're going back to the chair slides, and I got to figure out where in the share slides. No, that's too early. Let me just kind of summarize the outcomes here. If you'll bear with me for just a second to find the right icon to touch. So summary of the outcomes for the first topic was to propose a BOF at IETF117 and to coordinate with SEC to make sure that they can attend, since it is, of course, of interest to them. The second one, which I think was SAD CDN, was propose an art area BOF for that. Let's see, the third one, which was SDP security assurance, probably belongs in M Music, and the fourth one, which was the S expressions, is to do nothing and look in the direction of the ISE. Okay, so I think at this point we're going to be transitioning from being the dispatch meeting to being the art area meeting. And do I just present the meetings of interest? And okay, I wasn't sure if you wanted to get up and talk about that, Murray. Here are the meetings that might be of interest that are coming up. A couple of BOFs, several side meetings.
Jim, point of order. As one of the former chairs of the Keytrans BOF, it's been canceled.
Ah, thank you.
Thanks.
Yes, don't go to the Keytrans BOF. You will be in a class by yourself. Great, thanks. And Karsten, I think, has...
Yeah, I just was wondering whether you will be scheduling AOB points or will do that at the end.
Yeah, it looks like we're running a little ahead of schedule, so yeah, there is a little time at the end.
Okay, so I would like to mention multi-formats. Maybe we have a couple of minutes to talk about that later.
Just to mention as well, the S-Frame working group is not meeting. The S-Frame working group is not meeting this week, but just having an informal side meeting to discuss kind of where the working group stands, where the doc stands, and like what people are interested in, and kind of reinvestigate where the energy is in the working group right now. Not explicitly not an official working group meeting, but kind of checking in with interested folks.
Yeah, do you know when?
Sorry, thank you. That is Tuesday at 3 p.m. and it is in the side meeting wiki for the details. And we will have remote participation available. Just haven't figured it out yet.
And Hans-Jörg.
Hi, this is Hans-Jörg from Audriga. I just want to add there is another side meeting for the structured email topic where we had above in Yokohama. It's at Thursday at 2 o'clock in the afternoon. There is a remote participation option. It's all in the site wiki.
Thanks.
Will
Sorry
you
that
be
didn't make the list.
Hans-Jörg, will you be discussing chartering? Will you be discussing chartering? Is that on your agenda for that meeting?
Yes.
That's it. Just
Okay.
I'm planning my week. That's all. Is it me now?
Is you?
Good morning. 2 quick announcements. Francesca will be returning to us at the end of August. For those of you who are, yes, I have some pictures of her on her and her son on the beach hanging out. If anybody wants to see them, she sent them to say hello to everybody. She says strangely she misses this place. So she'll be returning to us at the end of August. If you are in a working group that she typically manages and you have a document that seems to be going nowhere, it's probably because I don't know that you have requested publication or whatnot. Please tell me. It only notifies her, not me. There's no forwarding set up in the tracker. I had a second thing. It'll come back to me. You can go on with AOB, Karsten one, or whatever is next on the agenda.
I think that's.
Oh, I'm sorry. I do remember what I want. The NomCom cycle is starting up again. The art area is going to ask for an additional area director in the next cycle because amazingly, we are now 36 working groups in, and which means we dwarf every other area by a long shot. So we will have 3 ADs at least for the next cycle. If you have anyone you would like to nominate, if you would like to self-nominate, please read. You'll see the announcements coming soon for invitations for nominations and so forth. Please participate in either by providing feedback or standing for a position. I think that's all unless there are questions. Back to you.
Okay. So any other business? And I think maybe Karsten had some other business, and go for it.
Yeah, I want to quickly bring up the multi-format work. I think there was some mention in the chat already or in the audio already. So we had a discussion in the last dispatch meeting that kind of said if this work needs to be done, it should be done in a working group. And the setting up of this working group seems to happen. Now, there were some concerns. I'm not sure that people really registered them at the last meeting, but just to as a piece of background, I'm known as an extremist in the COSI working group to register everything and then something. So that's my usual position on things. But for me, multi-formats really is way on the kitchen sink extreme of that arrow. So I think that an important part of getting some output from that working group will be to generate some guardrails for what should be done with these 2 registries that are in the current charter proposal and what maybe should not be done. And I'm just wondering whether those guardrails will be set up in the chartering process or will they be set up by the working group when it actually does its work. So if people have an opinion on that, I would love to hear that opinion.
Any I see Cullen moving toward the microphone.
Okay, I can't even get on the queue either. But Karsten, I think in the room we had a really hard time sort of understanding that. Maybe it'll need to be sent to the list or something, but I didn't really get what you were asking. Not that my opinion matters either way, but I don't think we really understood here.
Yeah, I think that I've seen a couple people make that comment here. So can we do it that way, Karsten?
Yeah, sure. I just was hoping to use a high bandwidth situation, but if the room audio doesn't work, then I cannot have that.
Okay. Are there any other topics for any other business? Going once. Going twice. We are adjourned. Thank you for coming, and have a good week.
Want me to just finish it, submit the draft, send it to you, and say it's good, and then you're going to submit it back to AD review for re-review? I'm just curious what's next.
I'm trying to remember exactly where it was.
So it was in AD review, and they gave back their comments.
Okay, so yeah, let's try and talk with Michael about it, because he has a little more experience with this part of the process. I think.
Okay, that's fine. I'll just.
But yeah, I think it would be something like that.
Okay, when I get it back up there, I'll just CC you and Mike.
Yeah.
Send it to the chair.
Yeah, I just
say it's there.
I'd want to look at it and see what changed and all of that, and what the comments were.
Okay, got it.
Good, thanks. Sorry, your thing didn't get on the list.
Good to see you.
Good to see
No
you.
worries, I was late with it, so it's fine. Anyways, anyway, I made on the list, so it's not so good. Yeah, I just forgot about dispatch.
Yeah.
You have a new email address. Can this be for like a blue book?
Oh, that's always been my email address for ages. Yeah.
I had another one. At least it surprised me. So anyway.
Yeah.
What is the underlying?
My wife and I were trying to come up with a domain name for our personal use. Everything we thought of was taken, so we just started putting two words together. It's like blue, blue pumpkin, and there's a company, Blue Pumpkin Software.
Okay.
Blue Popcorn. Oh yeah. Okay. We'll use that.
we have a meme in our company. You know, we do a lot of work with hosters, and so it's literally any kind of color you can. There's even multiple blue hosts and a red host and an orange host.
Oh yeah. Oh, that's yeah. It's fun that people use for like hosting